So yeah, hello, what's your name? That's the title of, well, a little bit of a funny title for a very technical deep dive on how DNS works in Wireshark. And it's not only for IP addresses. Most people use it probably for IP addresses, but other things can be resolved as well. So let's dig in and see what happens. A couple of guidelines for using Zoom. You've all done it. They've been to SharkFest before or whatever. But things that make it easier. I think it's better to use the Q&A for questions because things in the Zoom might get lost. And by default, if you type in something in the chat, it goes to hosts and panelists. And if you like to discuss things publicly, you have to change it manually to everyone. So I see a couple of messages to everyone and one message to hosts and panelists. So it's something to take into account. And of course, when the session ends, there will be you will be redirected to a survey. And yeah, it would be nice if you can fill it in so we can improve and I can improve my session too. So please fill it in if you are not redirected in the general channel on Discord. The link is there as well, so you can watch it there. All right, let's get started. Well, who am I? Well, you know me already, I guess, but I'm one of the Wireshark core developers. Been working on Wireshark or with Wireshark since I think 1999, back when it was still Ethereal. And I have my own company troubleshooting things and analyzing packets. So, oh yeah, one thing I shouldn't forget. As mentioned earlier, but maybe some people haven't already seen it. We need Pcaps for the packet doctors. The packet doctor session is looking at new trace files that we haven't seen before. So Chris, Betty, and I would be really thankful if you can share Pcaps. Of course, make sure that there's no sensitive information in there. And it doesn't need to be something that's solved already. It can also be something that's not solved. And if you send that to Jasper, he makes sure that we get them in the session, but not before. So talk to Jasper if you want to discuss how and why. I see one question. Will you email links for a survey? My company is blocking them. If you are on Discord, the survey will be there, but if not, please email Sherry so she can send you the survey. I think that's the best way to do it. All right. Okay, so actually we're getting off on the wrong foot here. Not by your question, but by the whole presentation name. Because name resolution normally refers to changing names into numbers. And what we want to do in Wireshark is change numbers into names. So actually it's reverse name resolution, but everybody calls it name resolution. So it should be simple, right? Just turn it on. If you look at the preferences, there's a couple of options. So on the view time resolution, you can enable the different layers. Normally it's only enabled at the physical level. And if you enable it, you will see that MAC addresses will be transformed into something with a little name in front of it. That's called the OUI, the organizationally unique identifier. IP addresses will be resolved into names, and port numbers will be resolved into services. But what about these entries? Where do these come from? Well, that's one of the mysteries of the whole name resolution process in Wireshark. So you probably have seen it before that you see a name in Wireshark and you're wondering where the hell does it come from? Well, that's part of why I'm doing this session. So ignorance is bliss, right? I mean, we all want to live happily without being disturbed by anything. But if you, when I made this presentation, it really dawned on me that it's really, yeah, glitch in the matrix, and things are not what they are supposed to be when you really dig into the name resolution process. So by default, for the MAC addresses, we have a manual file. It's in the global configuration directory. And that's because there's another slide on the memo file, but then there's transport names. We use a services file in the global configuration directory, and for network IP addresses, we use the captured DNS and MDNS packets and an external reverse lookups using your normal DNS server on your host. But what if you want to do other stuff? If you have a customer with an internal DNS server and you want to view the capture without having access to the DNS server, or you want to view the packet capture in the future and you're afraid that the DNS entries might have changed, or you want to manually give names to specific IP addresses, you have custom services on certain specific ports, you want to see Vlan names instead of numbers, you want to see GeoIP information, you want to see object names being resolved, all those kinds of questions. That's what this this presentation is all about. And the bad part is that there's so many places where Wireshark can get information from. There's static files, the host, the ethers, the MMDB files for GeoIP, MIP files, etc. And they're not in one place. They're scattered over system directories, global preference directories, default personal preferences, and specific configuration profiles. So there's a lot of places where you can do things right or mess things up. And of course, Wireshark can look at captured packets. For instance, the DNS lookups, they will be monitored and can be used to do forward name resolution to IP addresses. There's external resolvers. There's Pcapng name resolution blocks. There can, well, it's in plural. There can be multiple in one trace file even, with all kinds of intricacies. And there are some things hard-coded in Wireshark source code, so some things you can't change. And of course, you can do manual editing of network layer names. And of course, I have looked quite a few things up, but there's quite a few things unknown to me, I guess, as well. And there might be future changes, so lots of things to take into account. Well, regarding the file locations, if you go to help about Wireshark or Wireshark and then about Wireshark on a Mac, you will see a whole list of directories that Wireshark is using for different items. Well, I highlighted the personal configuration folder. That's the most important folder where you need to change stuff. That's where your personal settings are stored, and that's where also your profiles will be stored. So that's the very important directory. Then there's the global configuration that has some of the files that I'm mentioning in this presentation. And of course, there is system information. On the left on Windows, the system directory is the same as the global configuration. On the Linux system, you see that there's a system directory called etc, and it's different from the global configuration. So even between different systems, there's different places where things are stored. So have a look at your system where the files are stored. On my Mac, things are stored a little differently. I have a personal configuration folder in users sake/.config/Wireshark. Underneath that, there's a profiles directory. My system directory is /etc, and my global configuration is in my Wireshark application folder. And then deep inside there's a Wireshark folder with all the global settings. So those are the places where we're gonna edit things and add things. So what will we do? If you look at this packet on the left, there are several items that we can use name resolution on. First of all, there's the MAC addresses. And actually, I was surprised by that, but the DNS packets and the mainly the MDNS packets are also used for resolution of the MAC addresses. So that's where the glitch in the earlier slide came from. It's from captured DNS or MDNS packets. Then we have Vlan IDs that can be resolved. So that's with specific files in all those directories. The biggest chunk is name resolution of network layer addresses. There's quite a few options that you can configure. So things change depending on how you configure those options. Then there's the GeoIP information on layer 3 addresses, or mainly IP addresses and IPv4, IPv6 addresses. And there's, of course, your services that you can resolve. And in this case, there's also SNMP, an SNMP object ID that you can resolve into a proper name. And there's, I don't know why I put this slide in, but all right. So let's start with Vlan name resolution. Why do I start with this one? Because this is the most simple one of all. And I'm trying to build up the complexity of how Wireshark uses the name resolution. So let's start with the Vlan name resolution. It's disabled by default, and I get a message that participants can now see my screen. I hope that was already the case. I didn't see any questions about that, so that should be no problem. So the Vlan name resolution is done by Vlan files, and those Vlan files they give names to individual Vlan IDs. So you put a Vlan ID in there, and then a name after that, and it will resolve to that name. It's manually edited or with an editor, and you can put it in a configuration profile. You can put it in the default profile, and that's where those entries live. So I put them in the top entry is my configuration profile that I'm using for this presentation, SharkFest 21 VUS, and the second one is my default configuration profile or default configuration folder. So I put two files in there, Vlans. I put the same entries in there to see which takes precedence, and if I then open up a trace file with some Vlan tagging, I can see that the LFO2 is being resolved by the thing that is in my profile, and actually the one in my default profile is not used because there's also already a Vlans file in my profile. If there is no Vlans file in my profile, then the default profile will be used. And if there's, of course, no file there, then no Vlan name resolution will be used. If you look at the packet details, if you enable Vlan resolution, like was on the last slide, you need to enable resolve Vlan IDs in here. I have my iPad with me to do annotation. Over here is the option to resolve the Vlans. So that's the screen. So if that's enabled, a new field name will appear, namely name, and it will be filled with the name from the Vlans files. If there is no matching number or no matching entry, it will just be the Vlan number within those brackets. So if you put that all in a flowchart, is there a Vlans file in the configuration profile? If it is, then it's being used, and entries will be looked up there. If it's not, then the default profile will be used to look up the Vlans file. If it's there, then it will be used to look up the Vlan names. If those files are not there, or if there's no entry in the file, then it will use the normal Vlan ID with the brackets around it. So that was the easy part. That was just two files, and if one isn't present, the other one will be used. Chris is mentioning something. The Lua Tapper wrote, displays many resolve items in a single GUI window. If any resolve fields are missing, it might be possible to. I need to read up on that later. Thanks, Chris. I'll have a look at it later. So the transport layer name resolution is disabled by default. It uses the services files. There's a copy and paste error there. It gives individual services a name, should say. It's manually edited, and you can again use the configuration profile, the default profile, but it now will also use the global configuration directory. There's a services file there for you to have some default entries, and you can overrule them by using your own entries. While investigating this, I noticed that the services files, they don't seem to be loaded when you change profiles or when you reload the capture file. You need to restart Wireshark if you change profiles and want a service file from your current profile to be read in. So that's something to take into account, and we need to fix that. So as an example, I'm using only the profile directory for a services file. I don't use the default profile. I have one UDP port 1024 that's been resolved to profile 1024. And during the whole presentation, I use a prefix of where the naming information comes from, so you can keep track how it's been resolved. So in this case, you see on the right that the domain That's not in my file, so that must come from the global configuration file. But the profile 1024, that comes from my profile directory, the services file in the profiles directory, and all the other names come from from the global services file. Also, what you see is that ephemeral ports like Blackjack, that stands for 1025. I don't like it, but all the ephemeral client ports, they are also translated into names. So that's why you sometimes see very strange names, and those protocols are not in your trace files, just the client ports being resolved. Also something we could enhance, but there's so many things to do. And again, in the back details, you see that how it's being resolved. So if you put that in a flowchart, it's a little different. You look for the configuration profile. If the file is there, it uses that file, looks up the entry. If it's not in there, the entry, it will look it up in the global file. And the same goes for the default profile. If there's no services file in the configuration profile, it will check the service file in the default profile, use that, and if there's no entry found, it will use the global preference directory. If you look at the part here below, that's basically what, if you don't have any services files, that's what happens when you, this is the process that happens when you're not using a services file in any of the profile directories. Now it gets even, well, I can't say that all the time, but it gets more complicated with MAC address resolution. It is enabled by default, and it will use ethers files. So again, this can be done in the configuration profile. It can be done in the default profile. It can be done in the systems directory, but it can't be done in the global configuration directory. So now you have three places where you can do it. And while the ethers file gives individual MAC addresses a name, we also have the manufacturers, the menu file, and it will do OUI lookups and other well-known MAC addresses. It's generated at compilation time, so Wireshark takes a lot of sources, takes quite a few sources and compiles a list, and it will be shipped with Wireshark. And that's placed in the global configuration directory. So your ethers file can be in the other three directories, and the menu file will be in your global configuration directory. Then not only the static files, but also MDNS and DNS resolution in your Pcapng file will be used for layer 2 addresses, which was quite surprising to me. And also those entries don't seem to be flushed when you're opening a new file or reloading a file. So that's might also be a bug or inconvenience. So once they are loaded in memory, they stay there. And so if you want to clear them, you have to shut Wireshark down. So what about the menu file? It's a compilation of a few lists of Wireshark. Wireshark has a few lists of its own. And then there's the Ethernet codes master page by Michael Patton that's used. And of course, the IEEE OUI listings, they're also used for this file. It's being compiled by a tool in the source directory, and it will truncate each name to 8 characters, so it can fill in the first 3 octets and then show the last 3 octets. And the destination, of course, is the menu file, which is in the global configuration directory. So here I showed you that I have 3 places where I have an ethers file. I have one in my configuration folder up here. Up here, that's my configuration folder. Then there's one in the default configuration. Then there's one in the global configuration, and then there's one in the system folder. Actually, if you look at the resolution, you can see that the profile folder is not being used. This MAC address should be resolved if the profiles directory was used. Also, the global directory is not used because this MAC address should have been resolved when that was used. But you see a default, from the default directory, you can see some entries. You can see some entries from the system directory. And you can see that the broadcast, even though it's in all of the files, it's not been translated, and that's because it's probably hard-coded in Wireshark. So multicast, somehow that is being resolved, but broadcast is not. And the funny thing is that cast and broad means like bread, and cast means like a cupboard. So it's kind of a Dutch little word game. So this is when the left side is when use capture DNS packet data from address resolution is not enabled. If you do enable it, you can see that some parts are being overwritten. So the part where well, actually, yeah, there's one. The pbx.symbit.voip that's actually was in the profile, but it's been overwritten by the DNS entry, and something that wasn't resolved before is now being resolved because that was in the DNS captures. So it lays a layer on top of what you already are doing. And if you put that in a flowchart, you start, is the option use capture DNS packet data for address resolution enabled? If it is, then first look up if we have an entry there. If not, then go to the whole process that we've seen for the services as well. And if it is there, then use that name. So it's a little more complicated. Then what I said, the configuration profile don't seem to be searched for an ethers file, so that's not implemented yet. So that needs to be done, or we leave it like this. But it's a little bit out of the ordinary compared to the other layers. And if you don't have any specific files being edited, then in the blue area, that's what normally happens by default. Oh, there is a relevant Wireshark issue. Okay, so no questions so far, at least not that I see. So let's get to the interesting part about network address resolution or layer 3 resolution, because that's what most people use the name resolution for, and there's quite some intricacies there as well. So it's disabled by default. There, of course, again, many sources. There's forward DNS lookups. There's a resolve name that you can edit yourself with a right-click option. Yeah, you will be asked if you want to save the changes. So it does change the file, so it tries to save it back to the file. If it's a Pcapng file, if it's a Pcap file, it asks you to save the changes, and when you say yes, it doesn't ask you whether you want to save it in a Pcapng file. It just ignores that you're editing a Pcap file. So the Pcapng name resolution blocks. So those are the name resolution blocks in your Pcapng file. The host files in multiple locations, and then there's the explicit reverse DNS lookups. So you're looking up pointer records, and you can do that to a specific server if you like. So if you have an internal DNS server that's not the default on your own system, then you can use that server to do the lookups. One difference between the captured DNS lookups and the reverse lookups is that, of course, if you do a captured DNS lookup, if I'm looking up www.wireshark.org, it results in some A records. If Wireshark sees an IP address that matches one of those A records, it will substitute it for www.wireshark.org. If you do it through DNS lookups, if you look up the IP address from www.wireshark.org, it will point to one of the servers at Cloudflare. So you will see a Cloudflare name in there. So whenever possible, it's much nicer to use the captured DNS lookups than using reverse lookups, of course, because you see the host name as it was asked by the client. But then, of course, you need to capture the DNS traffic to be able to do that. Again, reloading a file or changing settings does not always fully remove the name resolution cache. So there are some entries that are being kept in memory, even if you change files or change profiles until you close Wireshark down. So there can be some unexpected behavior. So if you run into that, close Wireshark down, start it up freshly, and if all things are good, you shouldn't be bothered by it anymore. So if we focus just on the host file, so I disabled the external name resolver and I disabled the use capture DNS packet data for address resolution. So let's first see which files are used when we're using host files. Again, I created host files in all the locations, in my profile directory, in my default profile, or in the default configuration, in the global directory, and in the system directory. And again, I prefixed all the entries with the place where they come from. And there are some overlaps. As you can see, there's the 112.254. It's in these two profiles, the 122. Well, there's a couple of overlaps. Then if you look at the capture and which things are resolved, you can see that if you have a file in your profile, it overrules the one in your default configuration folder. So this entry is not being used because it's overruled by the configuration profile. Then the system directory doesn't seem to be used because the system PBX, the 102.1, that IP address can be seen here, it's not resolved. So apparently it doesn't use the systems directory. Actually, it does, but you need to enable the external network name resolver for it. It's part of the external name resolving option. So if I enable the external name resolver over here, then you can see that now the system, the etc host files in my system will be used also for name resolution in Wireshark. And this is on a Mac. I'm not sure how that works on Windows, where the system folder is the same as the global configuration folder. So that might work a little bit differently there. Then you can select only use the profile host file. And what that does is it disables your default directory. Or sorry, this should point to the global. Sorry, this was before it was the global gateway over here. And now by disabling the use of the host file, the profile host file, it will show only the thing from your profile and not from your global. So the arrow should be pointed to the different to one below. Then if I don't have any settings in my configuration profile, so I'm using a specific profile in my in Wireshark, but I don't have a host file there, then of course, well, not of course, then in other layers it was that it dropped down to your default configuration, but for the host file resolution, it doesn't. As you can see here, the default PBX 12 is not being used. So your default directory is not used, even though there is no file in your specific profile. So if you put that in a flowchart, this is how Wireshark is looking up names in all the hosts file. And there's one line here going out of this flowchart. That's of course, if you enable external reverse DNS lookups, if it's not in your system file, of course, it will do a DNS lookup to your name server. But as this is not in a host file, I pointed the arrow to outside the slide. So what happens if you enable the external resolver? So I'm enabling the external resolver. And what happens now is that even though this the 10.0.122.1 is in my DNS, it still uses the host file. So the host file has precedence over what can be searched with the external name resolver. Then if there's no entry for a specific IP address, of course, then the reverse lookup will be used, as you can see in this part here. You can see that for the lower two public IP addresses, it will use that entry, but for this IP address, it uses the reverse lookup over there. So the host file has presence over the external name server. In this example, I used a specific name server because on my I have a lab, and these trace files are from my lab. So if I didn't use a specific name server, I would not get I would not get this name right over here. This comes from my internal test lab name server. Otherwise, that wouldn't have been resolved. That's what you can do with the setting use custom list of DNS servers. So that's the setting over here, and then click on edit and fill in your specific DNS server that you like to use. Then the last step is to enable your the use of captured DNS data. Oh, again, I need to put some editing in this file because this should be a little bit above here. Okay, sorry for that. Since we're using so actually it should be over here. So since we're using the captured DNS data, you can see over here that I'm looking up pbx.rtd.synbit.voip, and the response was with an A record 10.0.122.1. Now Wireshark sees the IP address 10.0.122.1, and it gives the name pbx.rtd.synbit.voip, as it was resolved in a forward manner, instead of using the entries from my host file. So the captured DNS data has precedence over the host files. That's also what you see over here for public IP addresses. So I'm looking up neverssl.com. I get 4 IP addresses back, and all those addresses, there's 2 used over here, they are now resolved to neverssl.com, as I was typing in on my browser, instead of doing a reverse lookup that was shown earlier. So I really like that option because it shows you what the user wanted and not what the reverse lookup does. Then, of course, there's name resolution blocks in the Pcapng file. If you go to Wireshark, let me show that because not many people know that. If you go to Wireshark, and this is the normal display, I can go to View and then Reload as file format capture. Oh, I need to clear my filter because otherwise it's not shown. It will show you 1 packet or 1 entry, and then 1 entry is the definition of your Pcapng file. Well, in this case, it's a Pcap file format, so it won't show you any name resolution blocks. If I go all the way down, there's only packets. But if I go to a Pcapng file, so I have also one with as a Pcapng file. If I go to now, you see that there's several blocks, section header, interface description, etc. If I scroll down all the way to the bottom, Wireshark writes a name resolution block at the end. And what you can see over here are the entries in in that name resolution block. It's a little bit confusing that it shows you the system PBX here as well. That's because Wireshark sees that 10.0.102.1 actually from the host file points to system.pbx, but it has also an entry in itself that is nrb name resolution block underscore pbx. So this is the live, it's a live resolution of the IP address that's in the block, in the name resolution block, and this is the actual entry in the name resolution block. I'm not sure whether if I disable name resolution, if that behavior will change. Let's check. No, it will still show. Oh no, it's busy. Let's see. Oh, it's a bit slow. Oh. All right. Let's go to the name resolution block. See now, now it only shows IP addresses. So now you can see the real content in the name resolution block. It has an IP address and it has a name, and the other name was just that Wireshark used resolution to use resolution on the name resolution block in the Pcapng file. So there's a little inception kind of situation for you. Okay, let's go back to the other trace file and back to the presentation. So now you can see that the NRB underscore phone 103 is actually being used in the name resolution here, and also the NRB never SSL is also used in the resolution here. So it overrules the captured DNS data. And that's where things get a little funky, because later on I did it in a different way, and then the DNS captured DNS data overruled the Pcapng name resolution block. So if you look at the whole process, this is what I discovered yesterday. So it uses the forward DNS packets if they are present. If not, it looks for manually edited names. Then it uses the name resolution block from the Pcapng file, then the host file in all the directories, then the external reverse lookup, and if all fails, it will use the IP address. But then this part seems to be a little bit tricky, because it seems to depend on the order in which you're changing settings and editing names. So I didn't have the time to really get that on my to really get down to it how that works, but there are some unexpected behaviors there. So some notes on that resolution. So the order of enabling and disabling naming resolution settings and editing resolved names, they change how things are resolved, which in my opinion shouldn't be. It should be always in the same manner. So that's something we need to look into. If you do save as, even though Wireshark doesn't say that the file has been changed, it will save all the newly discovered hostnames into the new Pcapng file. So if you have a file with no name resolution block, you do a save as when you have the external lookup open, it will add those entries to your file. So that's a way of adding the name resolution block to your file. You can't save the file again because it's not changed, so it won't save it again because it's grayed out. So you need to do save as. Again, some name resolution or name resolving cache entries are not being cleared when you restart Wireshark until you restart Wireshark. So if something is mind-boggling why it happens, you might want to restart it. Did you turn it off and on again? Yeah, that one again. Then there's the use DNS packets. It is also not unlearning the learned names and addresses. So that's part of the cache that's not being cleared when you until you restart Wireshark. Are there any questions on layer 3 name resolution? Actually, I think, or I know that you can use IPX nets as well. So if you, instead of host files, you use IPX nets files, I think they're called, you can do IPX name resolution, but I don't know. If anybody still uses IPX in their network, please say so in the chat, but I think we all got rid of that, hopefully. Can you review how to see the NRB record again? Of course, yes, I can. So if you go back to the trace file, I need to go back to the Pcapng file. So I have my Pcapng file open here. Go to View, and then reload as file format or capture. Actually, I don't have it lying here. I have on my Twitter, I have a link to a digital version of my keyboard shortcuts, because as you can see, it's Shift Command F on a Mac. On the Windows, it's Shift Control F, I think. Then you can do it with one keystroke, which is quite nice. So if you want that overview, go to my Twitter account and you can see that, and you can download that. So if I go there, it will change. I guess I didn't do that right. I guess I did. It just needs some time. And I need to really, so I just use my keys to condense or collapse all the blocks, because otherwise it was a lot of scrolling. Now I'm opening up this whole block with shift arrow right, and you can see over here that the entries are in this book. Fun fact, that's what Jasper made me a trace file yesterday with multiple name resolution blocks, because we wanted to know how Wireshark did that. So there's a network resolution block test file. If I open that and I go to the, again, I need to close this. Now you can see that there's a name resolution block at the front and there's a name resolution block at the end. And if I open them up, you can see that here there are a couple of entries adding Jasper on the .100, also adding Bob at the .100, Alice at the .95. And if I go back down to the second resolution block, I can see that the 95 has been replaced by Mallory. So Alice has been replaced by Mallory. So that's some marital problems over there between Bob and Alice. So what entries do you think you will see in the name resolution? Will we see Jasper? Will we see Bob? Will we see Alice? And will we see Alice until Mallory comes in? Or will we see Alice all the way? Or will we see Mallory all the way? That's actually, that's a question that we had. And if I go back to the normal packet view, and I need to enable my name resolution again because I disabled it earlier. You can see that actually the whole file, it's Bob and Mallory all the way. So Jasper is nowhere to be found. Alice is nowhere to be found. So after Wireshark runs through the name resolution blocks, it will only keep the last entry for each IP address. So that's something that could be enhanced if we say, okay, we need to have a location-aware name resolution that is Alice up till frame 11, and then afterwards, with new name resolution block, it should change to Mallory. But that's again a feature request, and I'm not sure what to use, what the business case for that would be. All right, I see 3 questions. If you restart Wireshark and it clears the caches or resolutions, then we need to use a set or standard resolution flow. That's more of a remark. So we don't get unexpected results. Do you have a suggested workflow order per your earlier use cases? Yes, we do need things to be predictable. So I totally agree that we should do something about that. Do I have a workflow? Actually, this presentation was triggered by a question on Ask, where it was clear that the name resolution process wasn't very clear, and also not to me. And but to be honest, I don't use name resolution on the network layer very often. I usually use IP addresses, so I don't have a workflow myself. But based on my discoveries in this presentation, I would say, yeah, use your configuration profile to store the file, the specific files that you need to work with, because that's something that doesn't mess up other trace files if you use a different if you use a different profile. And yeah, apart from that, yeah, I think the whole purpose of this presentation is to know how it works, at least in this version 3.4.8. So you know if something weird's happening, that you can look at the flowcharts. Okay, where might it come from? And then so I would use just one host file in one location. I would enable the use capture DNS, because that's really nice. I would disable the use external lookups, because yeah, unless you really want to have the public addresses as well, or the reverse lookups as well. So that would be my workflow. Okay. So then another question is, will you post the updated presentation? Yes, I will. Before I will send in the presentation to Angelo, I will update it with the minor editings that were that were the minor mistakes that I made. Okay, let's clear up the questions. So that's answer live done. Okay. The review of the NRB records, is that enough for now? Greg, you asked that question. Can I assume it will be, and I will continue with the, yes, it was. Okay, good. So we have 15 minutes left. So let's do the DOIP and the SNMP information, and then maybe do a little bit more of a demo still, if there's time left. So Wireshark is able to add GeoIP information to IP addresses, and it uses the GeoLite 2 database. Up till Wireshark 2.4, we used the GeoLite without the 2 database, but then GeoLite changed their format, and so we did too. So since Wireshark 2.6, we use the GeoLite 2 databases. So all the supported versions are using GeoLite 2. You need to go to MaxMind, you need to add an account because of GDPR regulations and also the Californian privacy laws. So you need to create an account, and then you can download the databases, extract the MMDB files, and you put those into a directory. Those database directories where you put the GeoIP information, they are profile independent. They're stored in your default configuration, and they will be used regardless of which profile you have selected. And the GeoIP enhancements, you can enable and disable that at the IP and IPv6 protocol preferences. They are profile based, so you can enable and disable the GeoIP information per profile, but the source of the GeoIP information is shared by all the profiles. Default locations are hard-coded, so there are some locations per OS that are hard-coded, so you can either use those or you can add your own directory where you put those GeoIP files. Then I haven't tried it myself, but I should someday, because I usually work with enterprises which don't have any public addresses internally, so sometimes they do have locations, so it would be nice to have to create my own MMDB files to do GeoIP location of branch offices and stuff like that. So I need to check in that. I haven't tried it yet. It should be fun. So where do you configure that? In the name resolution settings, there's one option that says MaxMind database path, and you can add your own path there, and it will show up in the folders under About Wireshark. Above here, you see for macOS the 2 default locations where you can put your GeoIP information. So you can put it either as a shared GeoIP or for lib GeoIP. And in the Windows, I think it's in the C/GeoIP and one other, which I can't remember. And as you can see, I have a profile selected, but the location for the MaxMindDB path is still in my default configuration folder. So that's so one example. I have a packet to one of the 1.1.1 name servers. I'm a little bit surprised that they resolved this to 1.1.1.1 instead of 1.0.0.1, but both 1.0.0.1 and 1.1.1.1 are resolving to the 1.1.1.1 name. I enabled GeoIP lookups, and now you can see that it's actually GeoIP AS, the Autonomous System Organization's Cloudflare net. The AS is 13335. It's the IP address being used is in Australia, which is kind of funny because I'm in Holland. Why did it go to Australia? I'm not sure why. Because I think those addresses are AnyNet addresses, so they're probably spread out across the globe. So I'm not sure why I was going to Australia. Also the GPS coordinates, and so if you go to your endpoints and then the IP tab or IPv6 tab, you can click below on map, and it will draw an OpenStreetMap map with the IP addresses. So they're aggregated into green blobs, and the blue ones are one specific address. So I opened up this green blob of 2 addresses. It gives me 2 addresses. I click on one of the addresses and it says, okay, this was the address 13.225.234.89. It belonged to Amazon, was located in the United States, and there were 16 packets in so many bytes to this IP address. So this is actually quite nice if you are investigating a malware or DDoS attacks or stuff like that, then you might want to use the GUIP information. Again, I'm mostly working with enterprises, so the GUIP information I usually only use when I'm teaching, and apart from that, I'm not using it. Yeah, Mark, I noticed I think I noticed that one too, but thanks for mentioning it. Yeah. There was a typo in Pcapng. All right. Christopher, I wrote a batch file for use on Windows based on one of my updating you. Okay. Actually, I think so. This is really nice that you can do it from within Wireshark, but I think the MaxMind has its own update tooling as well that you can have an API key for. So it can update on its own. Yeah. Then another question: what about using a corporate DB for RFC 1918 addresses? Yes, that's what I was referring to in this last blog post by MaxMind, building your own MMDB database for fun and profit. Yeah, that's the one that you should look up to or look up into. Okay. Done. Okay. Then back to you built. Christopher made an improved version of the update scripts. Very nice. For those of you who do want to use GUIP, have a look at the tools directory on the Wireshark wiki and look up the update GUIP batch file to update your GUIP entries. Yeah. So I created. Oh, sorry, it's already been done. This we're going to SNMP. So SNMP lookups are also disabled by default. So what you can see here is that it is able to look up the first .1 over here. The first .1 is being translated into ISO, but it's not translated any further. And if you want to do that, you need to add some MIPS, and Wireshark already added some MIPS for you. So by default, some of the MIPS are already there. So you need to add the modules, the MIP files. You need to add a path where you will add the modules. Then you need to add the modules, and those settings again are global. And if you change them, you need to restart Wireshark. So the SMI module that reads all the MIP files, it's only being triggered when you restart Wireshark. Enabling of the OID resolution, that's a profile setting, so you can make that profile dependent. And well, actually that last remark is pretty important. The path in the module configuration is very picky. If you don't have the module names right, the SMI module is really picky in how it's being if it reads the SNMP files. So by default, yeah, we have no custom path, but we have some default paths. Some default paths. We use the global configuration directory for looking up MIP files as well. We have some SMI modules, some MIPS already been enabled. So you need to add the path, and then as a second step, you need to tell which modules you want to have enabled. Once you've done that, or this is the default, of course, once you enabled OID resolution, you can see that the default system description, all those kinds of things, they are already being resolved, as you can see over here. So this OID has been replaced by sys description of SNMP v2 MIP sys description. So that's your name of the OID. Then when you want to do specific MIPs, first you add a directory where you want to put them. If you add that, Wireshark warns you that you need to restart. Then you add the modules. So I added some Palo Alto network MIPs. Again, I need to restart. And then when I did that, you can see that there's some resolution taking place. But you can also see that it's not fully resolved. There's still some numbers left. Like it should end in just a .0, but there are some numbers that are not used. So I disabled the suppress SMI errors to see whether there was an error. Well, there was an error, but it was not related to the Palo Alto modules. So then I looked up online if the MIP is okay, and indeed it has the full OID is in the MIP. If I look into my MIP file, that PAN chassis type is really in there. But if I do, Wireshark doesn't see it because it stops at after the PAN common MIP instead of goes further to the PAN chassis and then PAN chassis type. So this is a mystery. So this is probably an error in the MIP file, or that the MIP file is not adhering to the standards, and then it can't be properly read by our SMI module. So that happens. And also, if you don't have the names right, I think I had to rename, but I did that already like a month or two ago. You need to have the names match the modules. So the file names need to match the module names and stuff like that. So it's a little bit tricky to get this working, but if you put some time in it, it will work. Okay. A reminder about the Q&A. Thank you. Yeah. So takeaways. So we're actually running quite on track because we're already at the takeaways. So out of the box, resolving works pretty good. So ignorance is bliss. So if you don't want to dive into this whole pool of madness, then just use the default options and you're pretty fine. If you encounter some unexpected glitches in the matrix, then you need to take the red pill and dive deep into how this works, as I did for making this presentation. There are some differences between how each protocol layer are, where they get their information from. So that's something that we might want to clean up. And if you do it right, it's a pretty powerful system to help you in your analysis. If I see Vlan names, it says so much more than a Vlan number. If I can say, okay, this is an Active Directory server, I give that a name in a host file, it's really helpful. Also for your documentation and your reporting, IP addresses are one thing, but if you use host files to put nice names for the IP addresses, the reporting will look much more, yeah, it's much nicer for the people who read the report. So, is there time for a demo? Well, it's almost time, so let's do Q&A first. And then if there's a question about if I can demo something, then I can also always do that. So are there any questions? There are no open questions anymore. Nothing in the chat. Well, there's always the possibility to add questions, ask questions afterwards. My email address is in the presentation later on, and the marketing slide, of course. It's no. So go back to the slideshow. Let's say the Q&A. Well, either you're all asleep because of this dry topic, or it was all clear, or I don't know. I don't see any questions. Everything has been answered already. That's good. Yeah, I think we can spend 15 minutes doing a little demo. Let me start, and feel free to leave if you're not if it's not interesting to you. One of the things that was interesting to me is that if let's disable for a second let's disable the use DNS for address resolution. Let's disable all these And now quit Wireshark, so it's fresh. Open it up again. Yes, Jeff, you need to watch it again and play with it all. I was really stunned by all the different ways of how it was working. Again, I get the SNMP failure. Let's open this one. And if I look at DNS or SIP method equals register. So I have my, let's see, over here. Over here, you see that I have a name resolution for pbx.symbit.voip, and it's not being resolved here because I don't use the DNS packet. So if I enable the uses of those DNS packets, name resolution, enable use capture DNS packets, now you will see that the register is actually using that information. But if I now open up another trace file, I made the same trace file and I removed the MDNS, I removed the DHCP, and I removed the DNS packets. So now it shouldn't resolve that. And oh, buggers. That's funny. Now it doesn't resolve it. Earlier when I did this, it's kept those entries. So it's really, it is a mystery sometimes why things are cached and sometimes they're not cached. So that's what you have with the live demo. We need to work on this to make the behavior predictable in all situations. But yeah, so let's see. Very clear where it could be. Okay, thank you. Have you also tried changing profiles with different resolution settings and see what the behavior was? No, I actually used one profile and I didn't see the behavior when changing profiles from one to the other. So that's something to investigate some further. Yeah. Yeah, okay. That's live. Okay. You're very welcome, Abed. I really like giving presentations at SharkFest and share my knowledge because, yeah, and get to have the knowledge from everybody else as well. So yeah, that's why I really like SharkFest. So yeah, let's skip it for now, or stop for now. I'll go over to the voice chat in Zoom or in Discord for the Zoom 1 voice chat. So if you want to meet up there, I will be there in a minute. And thank you for attending my session and have a good SharkFest.